Yeah, hello everyone. Today I like to show you how to let Spline grow with fields. That's something that I always missed in the built-in MoGraph environment. So now we want to build and set up with scene nodes and with fields. Actually, fields are not supported at the moment in scene nodes, but there is a small workaround how we can use the field information. So first I like to show you the idea behind this concept, and then we build the node setup together, and at the end I show you how to color the splines and render it. Okay, let's go. Okay, first we need a spline object that we like to grow. So we use a text spline for this. Call it spline text. Center it. And now we like to grow the spline from left to right with a field. So first we need the position of every letter here. So we can achieve this by putting the text under a connect object. Don't weld it. Then the connect under a fracture object. Set the mode to explode segments. And then the fracture we are tracing with a tracer. Set the tracing mode to connect all objects. And now you see we have for every spline we have a point here. So the concept is now we have a position for every spline. Now we need also a weight for every point. So we can convert the tracer here to a spline, and now we can add a vertex map. So now you see the points are getting red, so they all have the weight of 0. And now this vertex map, there we can use fields. So maybe we use a linear field. Make it bigger. And now I hope you can see it. Here are the weights. They are red and they are yellow. So now we have a fall off here from 0 to 100% weight. So we can read those data inside of nodes and let the splines grow with those values. Okay, so now let's start to build our node capsule. Because we converted the tracer here, that's not procedural, so we like to have a complete procedural setup. So I will start here from scratch. Now we have here our text. First we need an object group capsule. Search for group, and now here we have an object group capsule that acts like a generator object. Here we can feed in childs. So first we build two connect objects. This connect object is for our splines. And this connect object is for our tracer. Put them under the object group. The tracer has to go under a spline mask here. Then we feed in under the tracer connect object the final tracer. Oops, that's the other way around. Then the spline object under the spline connect object. Then the tracer needs to trace, as in the example before, the fracture object. So we can build this outside, but we put this all under this hierarchy here. So first we need a fracture object, put that under the tracer, feed it in here. Then the fracture object needs this spline So we can make an instant of this one here. Where is it? Here. It has to be a normal instance, no render instance. Put the instance under the fracture object. And then set the mode here to explode segments. And the tracer to connect all objects. And now we have the same as before. And now, because we have the tracer inside of a connect object and the connect object inside of a spline mask, we can use procedural weight maps, so vertex maps, sorry. So add a vertex map. Then a linear field. So yeah, you can't see it here in the viewport, but it works. So first, before we jump inside of the capsule object, make sure that both tracer weld is deactivated. And now we can jump inside of the object group. And now we want to read the child. The nodes are still a bit buggy, so before reading child, we put them here outside of the group first. And now we can use a child operator for this. Child operator, feed the object inside here and the children back to the input. Then go to edit resources, go to the children, and then set here the scene port mode to object. And now you can see it removes the children, so that means there are no children. So then we take those two here and put them back. And now you can see we have our two children here popping up. So here, when we go inside here, we see here we have the geometry, feed this, for example, to the output. And now here we see we have our spline back. Hide this one here, then remove this one, and we can split the spline with a node called split spline. But before we do this, it's good to rebuild the spline first. So that's actually pretty easy. So we use it's called geometry property get. Feed in the geometry and set this here to 3D points. And now we have here the points of the spline and the topology. So now we need a line topology get. Put this in here. Now we have the points, the outlines, those are the segments of the spline, so every letter, and the outline count and stuff. So it's a good information to build the spline and to split the spline. So first reassemble the splines. We use an assembly spline for this. Here feed in the points and the outlines into the segments, and now you can see we have our spline back. It's rebuilt, so that's good. So the split spline can work with this. If this input it don't work, I think that's still a bug. So yeah, but now we have the spline to work with the split spline. The split spline works like this. We feed in the geometry. Then the position means where to split the spline. So for example, if you just have the S, it starts here, goes around here and ends here. We say here the position like 0.5, it splits in the middle of the spline. And then the segment indices, these are just integer numbers for every segment. So For this example, I have 1, 2, 3, 4, 5, 6, 7, 8. Actually, those here in the center, of the P and E are also splines. So we have here around 15 splines. So let's then first build the segment indices. We need an array. The array that has to count from 0 to the number of splines that we have. So first make a build node, build an array. Then the data type here is integers. So remove all of those. And then next we have to append elements. Append elements. Put this in here. And then the next we have to do is decide the value for every array element. It has to be 0, 1, 2, 3, 4, 5. So we can use the outline count for this. So that's the number of all the segments that we have. So we build a range. Feed this inside the end. Put this under the value. And now we feed the array into the segment indices. Now we need the positions where to cut every spline, but we want just first we want to split the whole spline. So we can feed in here the positions for every spline, just the number 1. So let's make a fill array. The length of the array is the same here, the outline count. The value is a float value and it should be 1. And we feed this in here. And finally the geometry here into the split spline. And now we have here an array with different geometries. So for every letter we have our own geometry. So we can check this with a get element. This here. And now you can see here with the index we can switch every spline. Now we have an array with all the splines inside. Next, we like to iterate over those splines and make a split spline for every single segment here, for every single letter. So we need a loop for this. It's called loop carried value. We can remove this. We need just a normal loop. Then we need the loop iterations. So we can use also the outline count for this. Make a range, outline count, and then feed the range into here. And now it loops the number of all the segments we have for every letter. We have now a loop. So next we have to feed in our segments. And what we also need now, because we want to split it with the weight that we prepared here in the spline mask, we need the weight. So here in the second child, we can go here also to geometry, then use an point information. Where is it? Point info. Feed this in here, and now you can see here at the bottom we have weights. These are those weights here from the tracer that we built with the linear field. Okay, bring this here, then feed the weights also inside of the loop. Then let's dive inside of the loop. So first we need every single geometry outside of the geometry array. we use a get element, feed this in here, and then the iteration counts inside of the index. And now we have here every single segment. Then we use again another split spline. So now we split every single letter with the weights here. So feed in the geometry. Then now we need just the position. So and because it needs an array here with just one value inside, we have to build an array first. So let's use another get element, feed the weight inside here, and also iterate over it. And then we use a build, and now we build an here with floats an array with just one element. So remove the 3, and now we have just one element. Feed in the value inside here, and now we have the array for our position. Feed this here, and now every letter is splitted into 2 segments. So we just use the first one. So another get element, the index is 0, so that's the first one, that's good. And then feed this outside of the loop. Then go back, and then we feed the value here, the geometry objects, inside the geometry operator. And now you can see we can take our linear field and move it, and now the splines are growing depending on the vertex information. So for the end, I like to show you how to color the splines and to render it. Actually, you can color them, but it's not possible to render it in Redshift or standard render. So we have to sweep them. So delete this one. So first we need a sweep. Then here our splines are the path. So generates automatically a spline tessellation, switch this to none, and then we need an end side, feed the geometry here under the profile. It also generates a tessellate spline, switch it to none, then feed this outside here, and now we see we have splines, way too big. Maybe 2, a bit closer. So, and we don't need caps. And now we like to color it. So, whoops. So we need an color operator for this. Color operator. Now we can color it with just one color, but we like to color it depending on the weight of this or of the iterations. It doesn't matter. So first we like to have an hash value to have random numbers. Here it's called the hash node. So here we need a seed. And the seed we can use here the range. So feed this in here, and now you can feed in directly here the color. Now you see we have random colors. So, but we can use also a gradient between. Here, use the basic gradient. Then we need just the float here into the position of the gradient. And then back to the color, and then maybe use this one. So yeah, and then you can let them grow, and of course now it's fully procedural. Go here to the text spline, right, and so on. Here we go. And of course you can here, because it's a connect object, you can also feed in other stuff like this circle. So, or maybe you can draw something. Fit is also inside here. Yeah, and that's it. So that's it. I hope it wasn't too complicated. And yeah, play around with it. As usual, you find files on Gumroad. You can download them for free. And yeah, and if you have any questions, write me in the comments. So yeah, and bye bye.